This session's topic is big data and analytics. This will be a 1-hour session running from 10:30 to 11:30. Our distinguished panels include Michael Stevens and Brian Beals.
He will be. That's fine. We'll hear jump in.
Well, good morning, everybody. Aloha. I'm Michael Stevens from IBM. I'm with Government Solutions in IBM's Big Data and Analytics group. And we've got a very interesting hour for you here. Myself and my colleagues from Sirius Solutions are going to be talking about big data and analytics. I'm going to be providing an overview for about 25 minutes or so of the technology and how it's used. And then my colleagues here are going to be actually showing you a live demo of some of the technology. I've been with IBM about 13 years, came in from Informix, a company that IBM bought. I've been in the industry about 25 years doing consulting, doing all sorts of different sorts of solutions, government solutions, et cetera. And interestingly enough, the CIO of the state that gave a presentation this morning said he started out his career in GIS. I did as well with the U.S. Forest Service for a number of years. So, here's what we're going to be talking about this morning. What are analytics? Why are they important? What is big data? How can it improve analytics? We'll talk about a big data platform of technologies and how it works. And then we'll talk about who's using it, some government customers that are using the technology. The framework I like to use for this whole area is this. It's moving government from responding to things, responding to crime, responding to social program issues, responding to budget problems, responding to one of anticipating those problems and then being able to deal with those much more effectively and efficiently. That's what this is all about, moving from response to anticipation. So most people, when they talk about big data and analytics, start with the big data. I flip that around because I think the important part of this are the analytics. The big data is there to help improve analytics, but analytics are the key to this whole thing. So there's different types of you know what? I don't like standing on the stage here. I like to walk around, so I'm going to come down here. So there's 5 different types of analytics, starting at the descriptive, diagnostic, predictive, prescriptive, and then cognitive. What's the difference? So descriptive analytics. Where are we today? What's the budget today? What's the crime rate today? How many potholes are we finding out there? It's exploring metrics and key performance indicators against targets. So it's what is happening, discovery and exploration. Once you've discovered what's out there, you want to find out more information about it. The root cause of the event, what's happening. This is where you get into reporting and analysis. Those of you that have done business analytics know all about this. You can do what-if scenarios and do text analytics to find out more about it. Then we get to predictive analytics. Okay, we know what the problem is. We know where it is. Then we want to know what could happen with this problem. So this is predict occurrences of events stated as probabilities. So you build models and use past history to determine what might happen given a certain scenario and contributing factors. That's predictive analytics. Okay, now that we know what could happen, what do we want to do? What action do we want to take based on this information? This is decision management. You deliver high-volume, optimized decisions to your systems and your frontline workers in an automated or semi-automated fashion. So it's not making decisions for you, but it's helping to inform your decision-making. And in some cases, actually making decisions based on how you've programmed it. So that's decision management. Now that we have decisions made, what did we learn from this? How can we improve based on what's happened? This is about cognitive. This is kind of the leading edge of computer analytics. You may have heard of IBM's Watson, the Jeopardy game. That's cognitive computing. It combines a self-learning system where the system learns from what it's done, both its mistakes and its successes. And in some cases like Watson, you can use natural language to query the system. It's being used now in a variety of areas, including medical research, oncology, financial services, and even cooking, helping to come up with new variety or new combinations of foods that taste good based on a whole bunch of things. That's cognitive computing. So, now that we sort of have a basis of, is this too loud? Am I getting feedback here? Is it okay? Okay. So, now that we sort of have a little bit of understanding of analytics, what is big data? It's not a thing. Big data is data. You've probably seen these kinds of statistics where by 2017 there'll be 1 trillion connected objects and devices on the planet generating data. This is the Internet of Things that you've probably heard about. You probably heard 80% of all data is unstructured. Structured data, rows and columns like a spreadsheet. Unstructured data, everything video, audio, sensors, etc. There are 2.5 billion gigabytes of data generated every day. Now, how somebody came up with that, I don't know. But there it is. We might as well use it as a guideline. It's a lot of data being generated every day. You guys are generating data right now. Probably you have Fitbits on your arm. You have cell phones. You're generating data right now. And just with Twitter alone, 500 billion tweets a day. 500 billion. So that is big data. So big data is all data. It's data at scale, massive amounts of data. It's data in many forms, structured and unstructured. It's data in motion, increasingly coming from things like social media, coming from sensors, etc., real-time data. And the last one is data uncertainty. We don't want to forget about that because with all this data, some of it's good, some of it's not good. We have to know how to deal with it and distinguish between the good and the bad. In government, the challenge is that we've got a huge variety of data. It's diverse, it's structured, it's unstructured, and it's growing really fast. And I just listed a few different areas of government. Claims of a variety of social program claims, others tax claims, crime data, national security intelligence, social programs, environmental data, a lot increase in sensors being used to measure environmental changes and so forth going on. Emergency data, traffic data, logistics data, financial data. So with all those, we have an increase in the non-traditional data sources down here that are infusing these different areas. As I mentioned, sensors, imagery, satellite imagery, video, geospatial data, social media data, etc. So this is having sort of the ability to capture and leverage this data is having a profound effect in creating paradigm shifts of what we can do with it. So first of all, we're able to leverage more of the data being captured. Traditionally, there's a whole bunch of data out. There's always been a lot of data out there. There's been data out there for a long, long time, huge amounts of data. What's different now is we have the technology that's affordable and easy enough to use to where we can actually leverage all that data. That hasn't been true in the past. So before we'd analyze small subsets of information, now we can leverage all or most of the data that's out there. Secondly, there's a much reduced effort to leverage that data. It used to be that to do any sort of advanced analytics, you have some pimply-faced guy in a back room and a computer doing the advanced analytics. Now, because of technology, we're able to analyze a lot of messy information much more easily as is. Now, this doesn't mean that you're going to use all that data. This is an important point. When you have a big data pool, that you're structured and unstructured data, you can make connections with that data and then grab what you want and cleanse it as needed. But you're having the benefit of seeing a lot of connections you wouldn't see otherwise if you subset the data. Data leads the way, and sometimes correlations are good enough. What this means, typically, what we do now is we have a hypothesis about something, we turn that into a question, we query the data, we get an answer. That's typically how we've done it for a long time. Now we have the capability of having all the data there, exploring the data. Sometimes they call it a data sandbox. Finding correlations, finding connections and so forth with that data, and then gaining insight from that. And now we're able to leverage data as it's captured. So before we have data, put it in a repository, data warehouse, data mart, whatever, do analysis and get insight from it. Now there are some situations where we want to make business decisions based on data in motion. That could be Twitter feeds, that could be sensor data that's looking at toxin levels of something, and you want decisions to be made based on that data. You don't necessarily need it to go into a data warehouse. You can use it while it's on the fly. So what do these shifts enable us to do? Predict and decide the best action. Instead of just looking backwards, we can look forwards. Intuitive analytics for everyone. Instead of having that kid in the back room doing the analytics, we can do a lot of the analytics ourselves, your whole department. Now, does that mean everybody's going to be a data scientist? No. There's still going to be a need for people to do advanced predictive models and so forth. But with the cloud and the technology being easier to use, we have much more capability now of allowing huge numbers of people to do analytics. Then the whole area of cognitive computing, instead of pre-programmed analyses on structured data, we can have self-learning systems on all sorts of different types of data. And finally, you can have analytics as and when you use it. It used to be that if you wanted to have some sort of analysis done on something in your department, you used to have to send it to the IT shop and say, I want this analysis done. I'll have it done every 2 weeks. Or you set it up yourself and have it done once a week or once a month or whatever it is. Now you can have analytics on the fly, real time. So this is changing decision-making from intuition, instinct, hunches, based on experience. And don't get me wrong, those are still really important. But it's just that we're able to move up quality and value of decisions by going to the next level to automate or semi-automate decision-making. Knowledge, policies, and practices embodied in business rules, and decisions made efficiently and effectively. And then all the way up to predictive decision-making, where we make accurate predictions based on historic patterns and leverage all available data. So I'd like to talk just a minute about predictive analytics. Those of you that are baseball fans probably know Yogi Berra, and one of my favorite phrases of his is this: it's tough to make predictions, especially about the future. So predictive analytics helps connect data to effective action by drawing reliable conclusions about current conditions and future events. Techniques used are statistics, game theory, data mining, etc. We use predictive analytics every day, all of us do. From our credit score to Netflix, thinking what your next movie choice should be, Pandora, what your next music choice should be, Google for your search results, Amazon for what products you might want to buy, traffic predictions, portfolio management, healthcare, fraud detection, underwriting, et cetera, et cetera, et cetera. Predictive analytics are all around us. An example I like to use happened in New York City. This is what I'll call preemptive government. The problem was that in New York, where real estate is really expensive and there's a lot of apartments, people were subdividing apartments illegally. And that was a big fire hazard because they were doing it illegally. A lot of complaints. So they could have gone from building to building, floor to floor, and try and find out where these illegal subdivisions were of apartments. It would have taken them forever. They didn't have the manpower, they didn't have the money. So they put a predictive model together to identify the most dangerous of the illegally subsidized or subdivided housing units. And there were 4 characteristics they looked at. Owners who were in financial distress, so they subdivided their apartment to make more money. Multiple illegal conversion complaints against people. Multiple family dwellings built before 1938 when New York instituted a building code, so buildings built before that. And then low income, high immigrant, low employment neighborhoods, poorer neighborhoods. So they got a hold of a whole bunch of data, agency reports, real estate filings, finance and tax information, etc. And what they found were that dwellings that met all 3 of these metrics were 140 or 40 times more likely to have a fire. So those are the ones they targeted, and they found 225 of the highest risk buildings. So the moral is they were able to get to the worst of the problem in a much easier and faster way. Then they can go to the next ones as time went on, but they identified the worst ones. So with that as a background, let me talk about these technologies, what I'll call a platform for big data and analytics. We have our data on the left side here, transaction and application data, you know, your budget, your payroll, all those sorts of things. Your machine data, sensor data, enterprise content, image data, geospatial, video, social data, third-party data. I assume that most of you here are from state or local government agencies. Do you all recognize you have all this sort of data out there? Any of you using imagery data? Raise your hand if you are. No? Geospatial data? I'm sure there's some of you using geospatial data out there. One hand in the back. Social data. Are any of you using social data for the work that you do? Citizen sentiment, things like that. No? You should be. So this is what I call a zone chart. So these are zones of analysis. Okay? And they perform different functions for different types of analysis. So your operational data zone is where your ERP data is, where your budget, your typical, traditional agency data sits. Here, this is the landing, exploration, and archive data zone. This is this data pool that you can fit all sorts of structured and unstructured data in to play around in and make correlations and so forth. Up here is the real-time data processing and analytics. This is the real-time streaming data that I mentioned earlier that you could leverage. This is a deep analytics data zone where you have very, very complex analytics that you need done. There are things like data warehouse appliances. IBM makes it, some other folks make it as well, that combine a data warehouse, hardware and software data warehouse for very complex analytics. So that's a deep analytics data zone. Then there's your traditional enterprise data warehouse and data mart zone that most of you are probably familiar with. Underlying all of it is a key area of information integration and governance. Just because we're getting into big data and analytics doesn't mean we can forget about ETL, extract, transform, and load, cleaning your data, make sure it's good, master data management, identity resolution, things like that. So, having data filter through these different zones here improves these different types of analysis that I had mentioned earlier and creates new and enhanced applications on the other side. Now, just because you have all these technologies doesn't mean that you're going to use all of them for every application, right? So you may have some operational data, budget data, for example, that's in your operational data zone, and you want to do some deep analytics on it for some reason. It can go to this analytics data zone, deep analytics data zone, and answer a question, why did something happen with the budget, for example? Or you can have some data coming from sensors, let's say environmental data coming from sensors, going into this data pool, this exploration zone, and then feeding into why is something happening? Why is the toxicity level of a reservoir going up, for example? You may have applications where you want to make a decision based on something going on in real-time data like social media. And I'll give you an example of that, how one city is doing that. So, the technologies for each of these areas are, and this is not supposed to be a plug for IBM or for Sirius, so I'm staying pretty agnostic when it comes to, I'm not giving you product names, I'm giving you product technology types, okay? I'm being a good boy. So the operational data zone is your typical, it could be SAP or some other ERP system. The landing, exploration, and archive zone, and sometimes include case management, is Hadoop. How many of you heard about Hadoop? A few people. So Hadoop is a technology that was created, I don't know, maybe 10 years ago by folks at Google or Yahoo. I can't remember which one. And it's a way of storing structured and unstructured data in a very cost-efficient way on low-cost servers, a bunch of low-cost servers, right? So all of a sudden it becomes economically viable to use that to store data and then to do analysis on it. That's Hadoop. A lot of companies have their Hadoop implementations. IBM has one. A lot of other folks have them as well. Okay, that's Hadoop. Streaming platform is a way to leverage streaming data. IBM has one of those as well. The data warehouse appliance that I mentioned is here, the deep analytics data zone. And then down here again in the information integration and governance, this is where you have your data integration, Master data management. How many of you know what master data management is? Just a couple. So master data management is creating a golden version of, say, a citizen and their address, and have that being able to serve whatever applications are out there for government, right? So instead of me, if I'm going to register my car, the government already knows Michael Stevens is living at 123, Maiden Lane. And if I go to pay property taxes, it has that same information. So instead of having duplicate copies of Michael Stevens with different spellings and different addresses and different phone numbers, it has a golden copy. Entity analytics is a way of resolving identities and relationships. This is used a lot for fraud detection, as well as for understanding families from a social program standpoint. Who are you related to, et cetera, so you can optimize benefits. And then data security and privacy that you need to have whatever IT application you're doing. Whoops. In addition, there are big data navigation tools that allow you to go out and look at all the data that's out there without moving it, see what's out there. There are, of course, business analytics. Some of you, anybody use business analytics out here at all? Cognos, Hyperion, et cetera, one person? And then there's predictive analytics. There's packages like SPSS, like SAS, et cetera. Some of you may be familiar with those. So how are governments using big data and analytics? So one good example here is Memphis, Tennessee. The Memphis Police Department was seeing a rise in crime, and they didn't have the budget or the manpower to really combat it, and traditional tactics weren't working. So they put together a predictive model. It turns out that crime happens in specific locations on specific days under certain conditions, right? So on Tuesdays when say, Social Security checks are cashed or welfare checks are cashed, rain has an effect on it, sporting events have an effect on it, so crimes are likely to happen in different places in the city based on these variables. So you can put together a predictive model to help predict that and then deploy your forces accordingly, right? Put police where they need to be based on that prediction. So they did that, and they saw a 30% reduction in serious crime overall, a 4 times increase in the share of cases solved in their felony assault unit from 16% to 70%, and an overall improvement in the ability to allocate police resources where they need to be. This is a state health agency who is having, they had rising Medicaid costs, which most states have, and they had a growing sense that there was fraud going on out there, but they wasn't sure, inappropriate payments were being made, but they couldn't quite pinpoint it. So they put together analytical models to flag claims and providers that didn't follow typical patterns. This is called anomaly. So find out where the anomalies were. They didn't follow the patterns of prescriptions and payments and procedures and so forth that were typical. So they found obscure connections between doctors, pharmacists, labs, medical supply companies. Who do you think is the largest perpetrator of medical fraud? Anybody? Guess? What was that? Medical, doctors. Read it and weep. So they found a 99% reduction in fraudulent claims, $49 million recovered through 22 criminal convictions, 18 civil settlements, and $200 million in questionable claims identified within the first 12 months. So this is a youth organization in San Diego that has, it's a private charity that uses government money. And their goal is to provide permanence for these kids. These kids are in foster homes, et cetera. They've had a lot of changes. They've been bustled around one place to another. So the goal is to find a permanent situation. And they need to look for at-risk kids. They want to be able to identify at-risk kids in order to be able to help them. So the problem was they had all this fragmented data from different local agencies, state agencies, et cetera. They weren't able to make sense of it. Some of it was digital, some of it was paper, case notes written by caseworkers. So they used modeling and predictive analytics on a high volume of all these data to enable caseworkers to uncover these hidden patterns and relationships, because there were indicators in terms of violence, in terms of not being in school, a lot of different indicators, a lot of different variables that would point to being a high-risk youth. So once they identified who those high-risk youth were, they were able to provide the right programs and the right care for them. So they had a greater than 50% success rate with intervention cases where they had to intervene in a situation to cases by accurate early intervention or identification. 250% improvement in accuracy in identification of those at risk. And they're able to accurately predict whether individual youth have a high potential, greater than 60%, of needing help in the future. So like I say, this kid here has got a very high potential of needing help, so we're going to track him and give him some guidance ahead of time so he doesn't fall into bad situations. This is an example from a city in the U.S. that was worried about big civic events like music festivals, marathons, things like that, with making sure that people were safe. So this is an example of they used geospatial information, real-time geospatial information. They used Twitter feeds. They created a keyword list on Twitter, things like drunk, heart attack, faint, fight, long lines, whatever, to be able to send the appropriate resources, whether it was EMTs or public safety folks, to help the situation. All right, so that's an example of real-time data. They didn't drop that data into a data warehouse. They used that data to trigger some business decisions on sending an EMT over there because we've had word that somebody's had a heart attack, real time. Also used video analytics to identify cars that were going from an area that they were supposed to be into an area they weren't supposed to be in. You can actually train video cameras to recognize things like that. You can train a video camera to recognize if there's a group of people standing around a backpack and all of a sudden those people all leave. You can trigger an alert that, hey, maybe there's a problem there. Maybe somebody just left their backpack, but maybe it's a problem. You can actually train video cameras to do things like that. So there was an organization a couple of years back called Tech America, which was a combination of IBM, some other companies, academic institutions, government officials that looked at big data and put together a report that you see up here that was about understanding big data and how it can be used by government. I've included the URL to that report right here, so if you get a copy of this later, you can access it. And they came up with 5 steps that government agencies should look at if you're implementing big data and analytics. The first is understand the art of the possible. Don't limit yourself to the way things have been done. There's a lot more things you can do now with this technology and accessing all this data. Then identify 2 to 4 key business or mission requirements that will help you develop use cases that have a high probability of success. Ones that are important, but don't pick off more than you can choose. Keep it small to begin with. That will create value for the agency and for the public. Then take an inventory of your data assets. What's out there? What is the data that you have? What are the data that your partners have, other agencies, social media, sensor data, whatever. Explore those and within the context of those use cases you've selected. And then assess your current capabilities and architecture. Can you leverage all that data? Are you able to? If not, what do you need? Do you need a real-time streaming? Do you need an analytic device? Do you need a Hadoop to look at a bunch of structured and unstructured information? And then explore which data assets can be made open and available to the public to help spur innovation outside the agencies. There's some really interesting work going on in the UK where they have a science and technology center that has a bunch of big data technology that they open up to private industry to help spur economic innovation and so forth in the UK. So I provided my information here. I provided some links to some information that IBM has on big data. the Big Data and Analytics Hub, the overall IBM Big Data. There's a really interesting video on Watson and cognitive computing. It's about 7 minutes. It's very, very good. I've provided the link there, as well as my contact information, Twitter feeds, et cetera, et cetera. I blog on the Big Data Hub. So with that, I'm going to hand it over to Brian Beals. You want the lavalier? Turn this off.
Hello, good morning. How's everyone doing today? I'm Brian Beals. I'm the Director of Big Data and Analytics for Sirius, and with me I've got a colleague, Steve Kavlik. And we're going to do something a little bit different around big data today. Instead of beating you into submission with PowerPoints, we're actually going to show you a little bit about what big data is and some analytics techniques. So while the data I'm going to actually be showing you is retail data, it isn't government. I apologize, but I've yet to find a government agency to give me all their child and adult protective services information. So this is a fun little story, and it's actually going to revolve around a real life scenario. So you're going to see some of the capabilities that are possible within analytics. So to set this up, I'm playing the CEO of a company called Outdoor World. And Outdoor World is a purveyor or seller of hiking and camping equipment, been around a long time, they do really good. As a CEO, I was an avid surfer, so I figured if I loved surfing, everyone else must like the same things, right? Well, in Hawaii, probably. In the mainland where I live, not a whole lot of surfing occurs in New Hampshire. But anyway, so as an avid surfer, I decided I wanted to create a water sports division, but what I found is it really hasn't been performing to my expectations. So we're going to try to figure out today what's going on. I'm on the road, and I've got my iPad, and just to show you, it's really my iPad. My reports came out, so I want to take a look and see how things are going at water sports today within Outdoor World. And I just opened up my mobile environment. Again, I'll keep product names out of this. And I get to a palette. Now, I can do this on an iPad. I could be using my cell phone. Mobile applications are so ubiquitous now, they work on any platform. So Android, Apple, fully integrated. So if you've got people out in the field, it's really good that they can go, maybe go see do a case visit with the Child Protective Services or something of that nature. They can look at the files right here, make changes, upload it back to your server, kind of automate things and get it out of the paper world. So today I'm going to focus on Outdoor World Surf. And I'm going to open up my report, and basically what I have here is the dashboard. And within this dashboard, I've got 3 tabs at the bottom: sales, market analysis, and the new products. So I'm going to look at sales, see how water sports are doing. And I can tell right away up to the right that water sports is not performing to expectations. Actually, I'm 21% down. I'm not sure if you can see the red there. The screen's a little dark. But it's 29% below where we expected it to be. In the middle of the graphic, I've got what's called a tree map, which gives me a real quick, easy way to glance at the categories or how my business is performing. In blue, I've got my traditional hiking and camping equipment, which is really doing well. Water sports is in the lower right-hand corner in orange, not doing well at all. At the bottom of this, I've got a line graph that shows me things like inventory. I could look at other things like revenue. I could look at returns to see if I have any problems with the products that might be causing me not to sell enough of those. Again, I don't want to get too much into the data, but I do want to kind of show you the visualizations of what's possible. I've got radio buttons at the top, so I can look at different geographies. These could be different islands in your case. So I can look at Central Europe and see how it's performing for water sports. And I see, well, not a whole lot of water in Central Europe, so I have no water sports there, which is good. I can look at things like market analysis. And again, the reason I'm showing this is for the visualization, but what I have here is the bubble chart. And at the bottom, I've got a slide rule with a time series on it. So it starts at 2011, when I started the water sports division. In the orange bubble in the lower right-hand corner, should be, over time, going up and to the right, kind of like the Gartner Magic Quadrant. But as I move that, it continues to go down and recess, and the other categories are rising. Then I can look at products. And again, this could be any other type of visualization for your specific division and business for what you do with the state. Here, I'm listing the surfboards that we're selling. And I'm kind of the big kahuna, the retro throwback. I like the woodies. That's what I like to roll with. But I can look here and see what stores are actually selling these, and by the volume of the bubble indicates how they're performing next to their other peer groups. But I can also go through, I've got other products up there that I've listed. Well, basically, I can't determine why I'm not selling enough water sports or selling enough surfboards. So what I want to do now is I want to send this over to my analyst. Uh-oh. I'll be back in a minute. I want to email this report back to my analyst, Steve, and see if he can't come up with something. So I'm just going to edit my report. I'm going to mock it up, click send email. And Steve should know what to do with this. All right, with that, I'm going to let Steve come up and see if he can figure out why we've got an issue.
Hello, can everyone hear me? Great. All right, while I'm getting the projector connected, what I'm going to show you here is actually really more the art of the possible. And this is probably not something that someone would build out from scratch from the very beginning. So everything I'm going to show you is probably a logical progression, something that would take place over a couple of years probably. Okay, so I'm working as an analyst at Outdoor World, and I can see that I've just received an email from my CEO. And I recognize this. This is the sales dashboard that I created for our executives. And I can see that he's actually circled one particular number here. That's water sports. Now, I know that water sports category has been giving us trouble for a long time. And I also know that water sports is something that's near and dear to the heart of our CEO. All right, so he's indicated there's a problem with this product category. From here, though, we can just see there's not much I can do. It's just a static snapshot of the dashboard. But what we've done is actually included a link in the email that's going to take me from the email right to some web-based analysis. So you'll recognize this. This is the same dashboard or same starting point that my CEO had on his mobile device. Now I'm looking at this over the web. So let's begin where he did, just to get grounded and make sure we understand everything. Okay. So I have all my key performance indicators across the top in terms of product performance. And again, we can see that water sports has an issue here. Still have the heat map. One thing that's different than the CEO could do on his mobile device and some additional functionality that we've got in the web is the fact when I run my mouse over a particular product group or area, I actually get the actual numbers of the performance for that particular product or product group. I also have the line graph down below with the drop-down menus. Right, I could also toggle between the different metrics, inventory and returns. And it's not really giving me any other information, any root cause here. It's just telling me that something is wrong. I also have a market analysis tab, just like the CEO did. And I could easily use the slide rule to view the product performance over time. And of course, I also have new products. Now, again, all this is fantastic, but it's not helping me solve the problem. I need to answer the question from the CEO, which is, what is happening? Why is this occurring? So from here, I can actually follow this link. This is going to take me back to a workspace. And this is really my personalized workspace. So anytime I have to do analysis around sales, this is going to be the place where I start. Okay, so across the top, we have one type of visualization. And this is really just a traditional table, very easy to understand. You can see I've got different territories here. I have the actual revenue of those territories. I have a sales variance, so we're looking at the actual geographic performance versus a target. And we can see most of them are, at least 90%, which is pretty good. I have cost information, margin information, the amount of units that I ordered. And I have over here on the end a sales variance. So again, instead of just looking at numbers, one of the really big strengths of this platform is the ability to visualize data. Now, I know that if I look at a review of a restaurant or a movie and I see that things are 4 stars or 3 stars, I know that's pretty good. So we can represent our data that way here as well. So if I am new to business intelligence and I may not want to look at the numbers, these pictures help me understand at a glance the state of my business. So we can see that most of our geographies in this case are about 4 stars. Over on the left-hand side, we've got a revenue trend number. And again, just at a glance, I can see that my territories are performing historically pretty good. And in fact, most of them now are actually trending upwards. And we also have a stoplight or a status indicator. Nothing is green, meaning nothing is excellent, but I don't see any red, meaning there's a problem I need to deal with. Everything is in what we would consider to be a fairly good place. It's in a good mode right now. Let's take a look a little bit further down. You can see we have a combination graph, something that's putting different bars and lines together. And really what it's showing us is, again, for our different geographies across the bottom, each one of these bars represents a product group. Now remember before, our CEO wanted me to focus on water sports, and that's going to be the purple bar. And I can see in every single geography, water sports is the lagging group. Okay, again, this is telling me the problem. It doesn't allow me to investigate yet, but I'm going to do that. Now, as the business analyst, the pictures and the colors are nice, but I want to get into the numbers. I want to change the format. And using this on-demand toolbar, looking something very similar like what you would find in Excel, I have the ability to go out and change the format. Now, one of the things that I wanted to show you here before I do that is the way we can change all the different options, right? So we've got column charts, stack charts, right? We have gauges and pie charts, we have tables. Notice that this tab recommended, the platform is smart enough to give me choices that are only going to be good for my data. So you don't have to worry about putting your data in a format that isn't going to look good based on a particular graph type. I'm going to keep this simple, just leave it as a table. And we can see on the fly, I've actually personalized this and changed the report, the view that I want. Again, just like Excel, I may want to swap out the rows and columns, so there's a button for that. And I want to definitely investigate, look across geographies, so I want to do some drilling. So if I look at Americas, right, I can go to the United States, drill, one click gets me one lower level into the data. All right, now what if I'm worried about this drilling? Has it messed up my report? I don't have to worry about that at all, because again, just like in Excel, I have a back button that's going to undo all of the actions that I had previously done. Okay, one of the things that our company is really big in is collaboration. And I have other analysts that I work with, and a lot of times I like to leave notes for them, and I can do that on this particular report. So we can see here in this category of water sports, Southern Europe is actually selling less than Northern Europe, which to me is weird because Southern Europe is actually warmer, so you'd expect them to sell more water sports stuff. So I'm just going to right click, I'm going to make a comment. I'm just going to save that. Notice we've added a little caret here to let me know that there's a note in this particular cell. So I can save this for myself so that next time I come in, I know to look at that. Or actually, depending on the type of collaboration software that you may be using, you can actually assign this to people and create a workflow around that. Some of the other things that I could do in terms of sharing it, I could actually export it into a PDF. So if I wanted to share this with people in a format where they couldn't edit any of the numbers, PDF's a great format for that. If I wanted to send it to a place, into a destination application where people could build their own macros, do their own formatting, Excel is a great application for that. And it seems like no matter how great the BI platform is that we provide our customers, people still like to use Excel. So you can actually take the information right out of this BI platform and put it into Excel. And then if you just want to see the raw data, so we can export it into XML or even just a CSV. Okay, so if we think about what we've seen so far, my CEO identified a problem. He sent it off to me in an email. I've done a little bit of drilling. I've done some sorting and some pivoting here, but I'm still not getting to the root cause of the poor sales performance of this particular product category. Now, we've only looked at things like inventory. We've looked at sales. We looked at returns. That's really only just a small subset of all the different objects or metrics that I have access to. And now I want to actually go out and use some of those. So there's this gear symbol, which is going to allow me to do more. And basically, that's going to bring me to a place where I have access to many more reporting objects. Okay. Now, my company, Outdoor World, has actually done a really good job with their BI platform. They've organized all of their different reporting objects by line of analysis. So if I wanted to do some sort of inventory research, I would go here. But remember, I'm focused on sales. And one of the things that I want to do is just make sure that our pricing is right. So I'm going to go out and grab some of our pricing metrics. So let's look at the unit cost and the sale price. You know, I'm just going to drag these right onto the report. Drop these here. And I can see, all right, for water sports, for every single item or every single geography, the sales price is higher than the unit cost, and that's good. So our pricing is not problematic. As an analyst, one of the things I like to do is to build my own calculations. I'd love to build some sort of variance percentage between my unit cost and my unit sale price. And I think the formula for that is, let's see, it's the unit sale price minus the unit cost, and then it's divided by, I don't know, is it the sale price? I can't remember. I can't remember that. But you know what? That's okay. We have the ability with the platform to actually build it on the fly using a pre-built library of calculations. So I'm just going to right-click my two metrics. I'm going to say calculate. Let's do a percentage difference. And we can see we've generated a brand new calculation on the fly. And I could continue to customize this. I could do some stop lighting or conditional formatting, but I'm not going to do that here. Okay, so we've looked at things like inventory, we've looked at returns, we've looked at sales. I just checked the pricing. That is okay as well. Now, as an analyst, you know, I have to look at a lot of things. And one of the things that I've always felt is my CEO, he's a great guy, loves his water sports, but I'm not sure if we actually went to market with the right products.
He thinks I'm an idiot.
Now, just because he likes to do certain types of water sports, it doesn't mean that the rest of our customers do. Now, the systems that we have within our organization, we've got an ERP, we've got timekeeping, we've got warehouse management, we've got some customer information, but none of those actually tell us what's on the minds of our customers. But there is a place that you can do that, and that's through social media analytics. And luckily for us, this very same platform has the ability to analyze both structured and unstructured data. And we talk about unstructured data, that's exactly what social media is. And that's actually how most companies, or many companies right now, are dipping their toe in the big data ocean. So I'm just going to open up a new tab. And I'm going to go to some social media analytics that we've already run. Outdoors.
So again, we apologize, this is retail data, but you can imagine when you see some of these visualizations, what you can do with social data, you can understand how your customers, their demographic is affecting maybe the social situation for a particular island or a town, community, and social is a great way to get to that.
Okay, so really what we did is actually went out and we did a search or a fetch of certain terms as it relates to water sports, and this is the data that was brought back. So maybe one of the first things I'd love to understand is, where are people talking about water sports? We saw we had problems in the US. So here's a report that's showing me hot words by geography. So this is going to break out all of our hot words by country. And we can see, you know, the United Kingdom is talking the most about water sports, and that's kind of interesting, but I really want to focus on the US. Now, when I look at the US, I can also see what they're talking about. And the biggest bar here, this color is inner tubing. So right away, I think maybe we're onto something here. Maybe my CEO made the wrong assumption. So it appears that when people talk about water sports, it's primarily about this thing that he didn't quite understand. It's about inner tubing. Now, I may want to drill into this as well and understand what people are saying. And I'm going to drill a little deeper and actually just take a look at something that isn't there. So this is the fun of doing a live demonstration. So what that was going to show us is all the different snippets, all the different comments that were made. And the other thing this platform is going to give you is actually the ability to infer and do predictive analytics. So it looks at all the text, and it was going to infer the person's gender, whether or not they were married, and whether or not they had kids. So we're filling in some of the holes of our customers this way. Now, just because people are talking about a given subject, in this case inner tubing, we don't know what the sentiment is. So let's find out if people think about water sports in a positive, negative, or ambivalent way. So actually what we see here, there are certain hot words: tubing, wakeboarding, kite surfing. And when we look at inner tubing, right, we can see that it's green. There are a ton of positive sentiment. So when people think and talk about water sports, they talk about inner tubing, and they say it in a positive manner. So again, this is giving us evidence that maybe we should be selling more inner tubes. We may want to understand where people are talking about this. So we have the ability to look at the comments and understand what type of sites all of these comments are being made. So we can see here, we're looking at things like blogs, message boards, news sites, online reviews. Again, I have a drop-down menu here. I could look at the top 10 sites where people are talking about water sports. We can see Facebook, TripAdvisor, Wakeboard. So these are just giving us ideas of maybe we want to do some kind of marketing or do cross-promotions. And then finally, this is interesting. This is a type of report very similar to a word cloud, except it shows us over time what people are talking about. So when people talk about water sports, what other things are coming up? So we can see in this first week, people are talking about certain areas, right? We have Hunstanton. People were talking about honeymooning. People were talking about skills. Over here, we have the location of Phuket. People are talking about Auckland. People are talking about Hertz. You can also see in here that people were talking about Sbarro. So maybe when people talk about water sports, they're also thinking about being at the beach and getting some inexpensive pizza. So what we've done is actually identified a problem. I think that we went to market with the wrong products. We used analytics from a mobile perspective to start off with. We were able to email a snapshot of that dashboard. Right from the email, you have the ability to go into web-based analytics. From here, we personalized a report, and then we called in unstructured data from social media, all from the very same platform. So as a logical next step, right, we'd probably want to start selling some of these water tubes, water inner tubes. We just need to get those set up in our systems, and we should be able to go to market with those. Now that's everything I wanted to show you and how you can use analytics to solve a problem. I'm going to turn it back over to Brian, and if we have any questions, please feel free to ask any.
So yeah, are there any questions from the group on what you saw? Like I said, we really wanted to give you a flavor of kind of what's possible, and while it's retail data and not government, it's certainly all of this stuff can apply to government, right? If you're looking at maybe putting up a new eligibility site for healthcare, what are people saying about that? Are they getting easy access to it? Are there things that you could be doing to kind of anticipate that next step, like Michael was saying, and get ahead of a problem before it really becomes a problem? So those are some of the things we wanted to show you. If there are any questions, we're going to be here. There are a couple notes, though. They wanted us to tell you that lunch is going to follow this session immediately at 11:30 in Coral Ballrooms 3, 4, and 5. And then the lunch keynote will begin at 12:15. Additionally, we have our rep, Jason Yoshioka here, and we've got some flyers up here, a little bit more about Sirius. If you're interested, feel free to come up and grab one.
You know, I might add one thing about going from retail to government. It doesn't take much of a leap of imagination to think about how this could work for government. In my town, I took a walk one day and I noticed some graffiti on the sidewalk. And it looked like it could be gang related, right? So I took a picture of it and I tweeted it to the government. And they were out there the next day and cleaned it up. You know, potholes, just citizen sentiment. Think about your constituents, who you work for, understanding what they want, what they need. You can bet that politicians are using social media analytics all the time right now. And government agencies are beginning to do so as well. So think about how it might work, you know, for the area that you work in, for your department.
Yes, ma'am.
I think this is really great. The possibilities are endless, and it's amazing what you're able to do. I wonder, though, if you run into legal problems like civil rights violations because of how you clearly set up your big data analysis. Have you run into those legal issues? And have you come back and said, you're discriminating against poor people, black people, or whatever?
Well, obviously you have to follow the law, and you can only access data that's legal for you to access.
No,
Right.
that's not an issue. It's like how you set up your
If you're profiling, for example, is that what you're talking about? What?
like predictive models, especially, and what actions you're going to take based on the data that you're getting. But it's going to depend on what data you're looking at.
Right.
Have you run into those areas questions elsewhere?
I haven't. Some people may have. I haven't seen it. And think about in the case of the child protector, the charity that I was talking about. You're having to make a decision about that kid one way or another, whether they're doing foster care or some other program. If you're able to make that decision based on a whole lot more information, including predictive analytics, that's better for the kid. You're not accessing any data that's illegal. You're not doing anything that shouldn't be done. Now, certainly there are, when you get into social media analytics, Twitter data is open right now. Whether it should be, that's a political question, but it is right now. In the area of government, we were working with Los Angeles County and their juvenile justice system and their social program systems. The social program system wanted to access some data from the juvenile justice system, and of course that data is very, very proprietary. They don't want to share that with people. There are ways, like with master data management, where you can access subsets of that data that are authorized and even anonymize data that you need to protect, individual security and so forth. So there are ways of safeguarding movement of information.
But also, a lot of that's really going to depend on how you act with that data. So let's say you look at all your agencies as a whole and say, okay, if I have someone that's on SNAP and they're getting this other assistance, and what I've done through my predictive analysis, I've determined that these people fit a criteria that might really need child protective services, right? Maybe go out on a limb and you've actually, through predictive, you said, wow, these 5 people have characteristics of falling into that category. It's what you do with that data that is either going to put you on the odds of the law or not. You can't go and just assume and go take that child, right? You need to say, okay, what type of intervention might I want to have, or what type of extra eyes do we want to put on the situation, make sure we're not going to have a problem. It's really that fine line, which I'm sure that your investigators are very, very aware of. And,
you're not automating the system so the system says, okay, that person committed fraud. That information goes to an investigator who then uses that for their work.
It just highlights potential so they can be more aware, more astute, and you're not going to make any decision based on that data without human intervention. Human intervention is always going to come back and be the number one thing you're going to go to. But this is going to help narrow it down, to help you find the areas where you might be able to focus and better serve the community, or better reduce fraud, waste, and abuse, things of those natures.
Thank you very much.
Thank you. You have a great day.